For the Module 3 Lesson 9 problem set, we are going to start moving into some multiplication that represents what your parents are familiar with when talking about multi-digit multiplication, and that's going to be the standard algorithm method. What I will tell you before I get started is the standard algorithm method really comes down to being nice and neat. As you can see through our other videos, don't have crazy neat handwriting, but it's super important that you really try your best so you don't miss a part and get an error where you don't deserve one, okay? So for 1 and 2, I'm going to do both partial products and standard algorithm, and then for the rest of this page, you're going to try and do just the standard algorithm. Once you see standard algorithm, I know you're going to want to do it, but we stick with what we're comfortable and confident with. And if that's the partial product method, that is totally fine. So for this first problem, we're going to do 4 times 4 ones, okay? And in this case, that would be 16 starting in the ones place. For our next one, we would do 4 times 3. And one thing you'll notice is I'm not writing out the place value. So I'm not writing 4 times 3 tens over here. In this case, I know that 3 times 4 equals 12, but that starts in the tens place. So what I do is I add up my 2 partial products. So 6 plus 0 is 6, 1 plus 2 is 3, and 1 plus nothing is 1. Now here is the difference. Instead of having 2 separate partial products, we're actually going to kind of carry our extra digits like we did in addition. So in our 4 times 4, that's going to be 16. So 6, and carry this 1 onto the next place value. It's still in the tens place value, and this is why I said you need to be neat. You can't forget that. Now, when you do your 4 times 3, you know that the answer is 12, and you're going to add 1 more, which is 13, but carry the 1. 4 times 0 is nothing, plus 1 is 1. So our answer is 136, which is the same thing over here. I'm going to do it again before we kind of point out some nice features about this. So first off, let's look at partial products. So this would be the 4 times 3, which would be 12. Our next one would be 3 times 2, and that would be 6 in the tens place, making it 60. And the last one would be 3 times 2, but in the hundreds place, which would be 6 in the hundreds, add the space saver zeros, 2 plus nothing is 2, 1 plus 6 is 7, 6 plus nothing is 6. Now, in our standard algorithm, I'll start with our 4 times 3. It's 12, but I write the 2 in the ones place, and I carry the 1 to the tens. And you'll notice I'm doing this in colored pen, so it's easy to see. But when we do it in pencil, it can be tricky to try and figure out, did I mean to put this mark there or not? Your parents probably put it on top, but sometimes these numbers start to float up and we're not sure if they're part of this problem or a previous one. So that's why we keep it on the line, as long as you can keep it neat. This 2 times 3 is going to be 6 plus 1 more, which is going to be 7. And our 2 times 3 is going to be 6, and there's nothing to add to it, so that will remain 6, okay? What I really like about this method is it kind of organizes your place values for you. In our partial products, if I forget that the 6 is in the hundreds place and I put it in the tens place or even in the thousands place, that drastically changes our number. Okay, so as we mentioned, 3 times 2 hundreds, if I put this 6 in the thousands place or the tens place by accident, that would definitely change our answer. So what we have for number 2 is a series of different problems where you're going to try standard algorithm. I'm going to try 1, maybe 2 problems, give them a shot and go from there. So let's look at this one. 5 times 6 is going to be 30. Which means of 30, 0 is in the ones place. The 3 would be on the line. Then our 3 times 6 is going to be 18. And don't forget, you're not multiplying 3 more, you're adding 3 more. So 18 plus 3 is 21. So So I drop the 1, I carry the 2. Lastly, you're going to do 6 times 1, which is 6, plus 2, which is going to be 8, which gives us our overall answer. One thing I kind of like is if you look kind of sideways, you can see your answers, 30, 21, and 8 for each of those partial products. It just so happens that the place value that carries is on the line instead of a separate one. Let's look at one more on this page. Let's look at this. 6 times 5 is going to be 30. 5 times 1 is going to be 5. Don't forget to add, not multiply 3. So 5 plus 3 is 8. I have nothing to carry. 5 times 3 is going to be 15. 5, carry the 1. There is nothing for 5 to multiply by, so it will be 5 times 0 is 0 plus 1, which is 1. So our answer is 1,580. On the flip page, you'll notice you have a few more problems. So it says, the product of 7 and 86 is. So what you're going to do here is you're just going to rewrite this problem as 86 times 7. For this time, 9 times as many as 457. Well, that would be 9, 457. We usually put the large number on top. And you're just going to do the standard algorithm for that problem. For the last 3 problems, we have some word problems. So let's look at number 5, and I'll leave the others for you. It says, Jason wants to make 5 airplane propellers. He needs 18 centimeters of wood for each of the propeller. How many centimeters of wood will he use? So in this case, I'm going to take my 18. I'm going to need to multiply it by 5. I know 8 times 5 is 40, so 0, carry the 4. And 5 times 1 is going to be 5 plus 4, which is going to be 9. So our answer is 90. So that is 90 centimeters of wood is needed for the project. All right. The last 2 problems, we'll just do more multiplication. So in this case, this would be 238 for one game system. For 4 of them, you're going to multiply that amount by 4. A small bag of chips weighs this many grams. A large bag weighs 3 times as much as a small bag. So, 48 times 3. How much will 8 large bags of chips weigh? So before you can even start figuring out how many times the large bags weigh, you have to figure out how much 1 is by 48 times 3, and then take whatever that product is and multiply it again by 7.